Alright, Lucy, this is follow-up to the video you had asked me, or the question rather you had asked me about on asymptotes, and there was no way I could explain vertical and horizontal asymptotes in that short time. I decided what I am going to do is I'm going to explain it for the duration of this video, and then I'm going to redirect you to a link if you have additional questions of a video someone posted online that explains this pretty well. So in this case, for this equation specifically, we talked about here's the rational expression, the polynomial rational expression, and we had factored out what could be possible factors, and then we factored it. And so now we need to find where the vertical asymptotes are, the horizontal asymptotes, and the holes. I'm not going to talk about diagonal asymptotes. So, and I don't think it's necessary in this case. So if you want to learn about that, you'll need to look at that additional video, which I'll include in the email I sent to you. So the vertical asymptotes are the easy ones after we divide out any common factors, such as these. The remaining common factor, the remaining factor in the denominator is x plus 3. So if we just set x plus 3 equal to 0 and solve to get the root, then essentially this just becomes x equals minus 3. So you'll have one vertical asymptote at x minus 3. So how about holes? Well, we already mentioned that these right here divide out, and this will be where your hole is at. Okay, so x equals 4, and then, so I'm going to write this out here, hold on. So vertical asymptote, hole, 4, because we solved for it after setting it equal to 0. And then our horizontal asymptotes is where you were having a little bit of difficulty when we discussed this online. So the horizontal asymptote will be a division between the remaining, after dividing out common factors, a division between the remaining terms. So in this case, the numerator of x plus 4 and the denominator of x plus 3. What you want to look at is there's basically 3 situations, and the video online addresses this well, where the leading power in the numerator is higher than the leading power in the denominator, or where they have the same power, or where the leading power in the denominator is higher than the leading power in the numerator. If the leading power 1, if the leading power in the numerator is higher than the denominator, then you have no horizontal asymptote. So if this was x squared, for example, which it is, and let me get to that. But if this was x to the first, and there was no trailing values here, and this was not x squared, then there would be no horizontal asymptote. But even after we do the work here, we can see that there is going to be a horizontal asymptote, which holds true to the original form, because both of these have x squared. In that case, when they're equal, you divide their leading coefficients. So in this case, the leading coefficient that's not written is 1 for both of them. So 1 divided by 1 gives us our horizontal asymptote of 1. Now, the other cases that aren't covered here, that are covered in that additional video, I encourage you to look at, which is where would the horizontal asymptote be if this power was higher than this power, or if this power was higher than this power. And I'm not going to go into that on this short. All right, thank you.